Welcome to this explainer. You know, when we look back at history's greatest engineering disasters, it's easy to just see the tragedy. But the truth is, these catastrophic events didn't just destroy lives and structures. They literally built our modern, heavily regulated world. The strongest bridges you drive across, the safest airplanes you fly in, the most reliable ships, and even modern nuclear power plants, well, they all share one crucial thing in common. Today, we're diving into the crucible of failure.
Which begs a pretty fascinating question. What do the safest bridges, airplanes, ships, and buildings in the world actually have in common? Answering this totally shifts our perspective. It moves us from viewing these historical events as mere tragedies to really understanding them as life-saving turning points. I mean, it might seem totally counterintuitive when we look at the monumental engineering achievements all around us. But the real foundation, it isn't just brilliance or innovation.
The unexpected truth is that they were entirely shaped by failure. Every single mistake we're going to examine today exposed a hidden weakness. And that forced engineers to rethink old ideas, drastically improve designs, and create the strict safety standards that protect millions of us today. Honestly, the greatest legacy of these disasters isn't the destruction they left behind, it's the much, much safer world they helped build.
Let's start with the RMS Titanic. There was this incredibly stark, deadly contrast between the ship's supreme confidence and a fatal, almost microscopic flaw. The pure hubris of the early 1900s gave us a ship with electric elevators, a swimming pool, and these supposedly advanced watertight compartments. I mean, newspapers literally called it practically unsinkable. But hidden right there in its design was a massive oversight. Those impressive watertight compartments, they simply weren't tall enough. So when that iceberg scraped the starboard side, seawater just spilled over from one compartment to the next. It was exactly like water flowing from one overflowing bucket into another. The ship's own cutting-edge safety design actually became its downfall.
The staggering scale of this tragedy just completely shocked the world when the ship disappeared beneath the Atlantic on its maiden voyage in April 1912, claiming more than 1,500 lives. In just a few hours, the Titanic proved that supreme confidence can absolutely never replace proper preparation. The whole world watched in horror, finally realizing that ignoring warnings like, the multiple icebergs reported dead ahead of the ship that very night, well, that carried the ultimate price.
But here's the thing. From the absolute depths of that tragedy came a complete transformation of maritime safety. The aftermath forced the creation of much stricter international safety laws. Suddenly, it was absolutely mandated, no exceptions, to have enough lifeboats for every single person on board. It demanded continuous radio monitoring, and it led straight to the creation of the International Ice Patrol. By forcing lawmakers and engineers to learn from the Titanic, they basically ensured a tragedy of this specific kind would never happen again.
Okay, so the harsh lessons learned on the ocean soon had to be applied to a totally new frontier, the skies of the early 1950s. Enter the Havilland Comet. This was the world's very first commercial jet airliner. It flew higher, it flew faster, and it cut travel time almost in half. Airlines were literally rushing to buy it. But then, suddenly, this absolute pride of modern aviation just began breaking apart in midair. One vanished over the Mediterranean, leaving nothing but floating pieces. Then another exploded, and then another. And the most terrifying part? Absolutely no one understood why.
Solving this terrifying mystery required some of the most unprecedented engineering detective work in history. First, investigators pulled thousands of pieces of wreckage up from the bottom of the sea. Second, they literally rebuilt the entire airplane, piece by painful piece, inside a massive hangar. And when even that didn't reveal the answer, well, they did something completely groundbreaking. They placed a complete Comet aircraft inside a giant water tank. They continuously pressurized and released the cabin pressure thousands of times to simulate real flight conditions, over and over, until the metal finally cracked.
And there it was. The culprit was this invisible, hidden killer. Investigators finally discovered that enormous stress was building up right at the sharp corners of the Comet's square windows during every single flight. The cabin's constant expansion and contraction led to these microscopic, tiny cracks. Passengers couldn't see them, pilots couldn't see them, heck, even the engineers missed them. But each flight made those cracks slightly larger until the metal suddenly just gave way, and the plane broke apart in mid-air. It was metal fatigue, a deadly danger that honestly no one fully understood until it was way too late.
So what did the aviation world learn from this absolute horror? Well, engineers immediately redesigned aircraft to feature the rounded windows we see today. Why? Because a curve distributes that stress evenly.
They built stronger overall structures, and they implemented far, far stricter fatigue testing. In fact, almost every single passenger airplane today uses rounded windows specifically because of the painful lessons learned from the comet. Because engineers never forgot those failures, millions of us are able to fly safely every single year.
Now, while the comet fell from the sky, just about a decade earlier in Washington state, a completely different kind of structure was being torn apart by the air. Right after it opened, drivers started noticing the very elegant Tacoma Narrows suspension bridge swaying and rippling. I mean, it looked like ocean waves. It even earned the very catchy nickname Galloping Gertie. But when 40-mile-per-hour winds hit that bridge on November 7, 1940, it just completely tore itself apart. The crazy thing is, the real problem wasn't just the wind itself. The culprit was something called aeroelastic flutter. It's this highly dangerous, complex interaction between the wind and a bridge's overly flexible design.
Thankfully, miraculously, really, no people were killed when Galloping Gertie violently crashed into the water below. But man, the shockwaves sent through the engineering world were massive. It proved, without a doubt, that nature's forces absolutely must be respected. To prevent anything like this from ever happening again, modern bridge engineering now mandates thousands of hours of rigorous testing in wind tunnels. And all of that happens long before a single piece of steel is laid or construction even begins.
But sometimes it's not the wind or the ocean waves. Sometimes a single, almost microscopic human decision causes the disaster. Picture this: a luxury hotel in Kansas City, 1981. Hundreds of guests are gathered for a dance competition, and a bunch of them are standing on these really cool suspended walkways right above the lobby. From the outside, it looked perfectly safe. But hidden from view, a seemingly minor, last-minute construction change had secretly, literally doubled the load on the critical support rods.
Without any warning whatsoever, the structure just couldn't carry that immense weight anymore, and the walkways crashed directly down onto the crowd below. This disaster tragically killed 114 people and injured more than 200 others. It became one of the deadliest structural engineering failures in all of American history. The sheer tragedy of that number forced the entire construction industry to finally wake up. It ultimately transformed building regulations, it mandated incredibly rigorous design reviews, and it revolutionized inspection procedures all over the world. It was a brutal lesson that even the absolute smallest engineering alteration can have serious life-or-death consequences.
Okay, our final engineering failure today didn't involve weather or waves or wind. It was a catastrophic loss of control inside a nuclear power plant. On April 26, 1986, at Chernobyl, what was supposed to be a routine late-night safety test spiraled completely out of control. Workers wanted to test power production during a simulated blackout, but to do this, several absolutely critical safety systems were deliberately turned off. Operating under these highly unstable conditions, well, one mistake just led to another. Power surged way, way beyond safe limits, and massive explosions completely ripped through reactor number 4. The consequences of that single night extended so far beyond a standard explosion. A terrifying, invisible cloud of radiation spread across huge parts of Europe. Over 100,000 people were urgently evacuated. Entire cities, like Pripyat, were just abandoned overnight. And those brave first responders? They paid the ultimate price. Just to contain the site required building a massive concrete sarcophagus, and later, a giant steel confinement structure. This incredible technological disaster served as a stark, global reminder. Even the most advanced technology can fail disastrously when safety is ignored for the sake of speed or convenience. It forced governments everywhere to strengthen emergency planning, drastically increase international cooperation, and completely redesign our nuclear safety standards. So, what does this all mean for us? Well, every disaster we've looked at today leaves behind a singular, truly life-saving blueprint. From the Titanic, we learned that supreme confidence can never, ever replace preparation. The comet showed us that tiny details save lives. Tacoma taught us to deeply respect nature's forces. The Hyatt Regency proved that small, seemingly harmless changes can have devastating consequences. And Chernobyl? It established once and for all that safety always comes first. The safest bridges, planes, ships, and buildings exist today not because engineers never failed, but because they refused to stop learning from those failures.
As we wrap up this explainer, I really want to leave you with a thought to ponder. The next time you step out into our remarkably safe modern world, maybe you drive across a massive suspension bridge, or you board a commercial flight, ask yourself, do you just see steel and concrete? Or do you see a living, breathing legacy of the disasters we actively chose to learn from? Every single great failure left a blueprint, and those hard-won lessons continue to protect millions of us every single day. Keep questioning the world.